In this presentation we're going to look at spanning trees. A spanning tree is a tree which spans the graph G and it connects to each vertex of the graph G. Importantly, it has all the properties of a tree. It's a simple graph with no cycles and no loops, recalling our definitions from graph theory. Now, important little definition I'm going to put in here now is a path graph. A tree that only contains vertices of degree 1 or degree 2 is called a path graph. If two path graphs contain the same number of vertices, then necessarily they are isomorphic. So what we're going to do is find all the isomorphic spanning trees of the graph G. I'm going to show graph G now here in a sec. So there we have graph G, 5 vertices A, B, C, D and E. It has cycles, so it's not actually a tree, but it can have a spanning tree as a subgraph of that. So let's look at the first spanning tree of graph G. Well, we have a path graph here, and it's a simple graph. It's a simple tree with that's a path graph. So, and it spans all of the vertices of graph G. I've added in little subscripts there, 1, to sort of emphasize this is from tree 1. Because we're going to sort of demonstrate some other possible spanning trees, and I just need to distinguish between one tree and the other. So we're going to show 2 more possible spanning trees of graph G. So we have spanning tree 2 and spanning tree number 3 down here at the bottom. The thing about these 2 new spanning trees is that they are isomorphic to tree 1. I'm just going to sort of demonstrate the correspondence by using the vertices, how they would correspond. So we would make this correspond to E1, this correspond to A1, B1, D1 and C1. Okay, by sort of recognizing that correspondence between vertices of tree 1 and tree 2, we can see that they're isomorphic without referring to the fact that the path graphs are automatically isomorphic anyway. Likewise, we can say the same thing about the third tree, tree number 3, that it's isomorphic to tree 1 and tree 2. Let's look at another possible spanning tree that is not isomorphic to anything we have so far. So we have another spanning tree here, spanning tree 4. Automatically you can see that it is not a path graph because vertex D4 has degree 3. So it's not isomorphic to the the trees we have seen earlier. There is a degree of 3 at this vertex here, D4. So it is automatically non-isomorphic to the previous trees, spanning trees. We could come up with other alternative spanning trees, alternative configurations, but we will find that they are isomorphic to this tree, tree 4, if they are not in fact path graphs. So we actually have only 2 non-isomorphic graphs, tree 4 and one of the previous trees we've seen previously, tree 1, 2 or 3. And that ends our presentation.